Hi guys, welcome back. And in this video, we will be taking a look at some physics problems related to kinematics and projectile motion related to JEE mains. Let's get right into the video. So the first question is that two passenger trains pass at the same moment through points A and B 200 kilometers apart. They run on parallel tracks towards each other at a speed of 60 kilometers per hour and 45 kilometers per hour respectively. We have to find the time in which they meet. Now what we can do is we can first find the relative distance, which is s1 plus s2. Directly we get that as 200 kilometers as given in the question, and the relative velocity will be the sum of the velocities of both the trains because they are moving towards each other. So that is 105 kilometers per hour. Now the time taken for them to meet is given by the formula distance by velocity, both relative. So 200 divided by 105 gives us the answer 119 by 21 hours. Let's move on. The second question states that a body is projected upwards from level ground with an initial velocity 20 meters per second at a theta of 30 degrees to the horizontal. We need to find the magnitude of the velocity after 1 second of motion. Now the velocity of a particle in projectile motion can be given as under root v square plus g square t square. But what we can also do is we can find the x and y components of the velocity and take the square of them, add it and find the under root of those to get the magnitude of the resultant velocity. Now Vx is Ux because there is no acceleration acting along the x-axis. Acceleration due to gravity g acts only along y-axis downwards. So we get Vx as v cos theta, which is 20 cos 30 degrees. Then the velocity after 1 second is v sin theta minus g. That is the initial y component of velocity minus gt. T is 1 second, so we directly get minus g. This turns out to be 0. The resultant velocity is sum of Vx and Vy. Here we don't take under root because anyways the value of Vy is 0. So taking under root would only give Vx anyways. And we get the answer as 10 root 3. Now let's jump into the third question. The third question states that a particle is projected horizontally from a height b. So we have h max equal to b, and the velocity acts only along the x-axis. We have 0 value initially for Vy. Now we have to find the range of values for horizontal speed v so that it falls in this hole. Now the way we can do this is we can take two cases where the horizontal range is only till this point, that is the horizontal range is only a, and the second case is where the horizontal range is 2a. That gives us the points at which the particle would hit the edges of the hole. Now excluding those values, we get the values of v for which the particle would fall into the hole. Now time of flight is given by the formula root 2h by g when a particle is projected horizontally, and the height is given as b. Now acceleration is less than vt, which is again less than 2a. We could also do this in another method by substituting the value of r as u root 2h by g, that is vt. So we get the range as vt in this case and range as vt in this case as well. When we substitute a equal to vt, we get one answer, and when we substitute a equal to vt, we get this second answer. The fourth question states that a body is in projectile motion along an inclined plane which is at an angle of theta 1 with the horizontal. The body is projected at an angle theta 2 with the horizontal. We have t as the time of flight and u as initial velocity. L is the range. So we need to find L in terms of u and t. Now range is given as u cos theta 2t, whereas L is given as r by L cos theta. So we get the value of L as r divided by cos theta because when we take cos theta, we get r divided by L. So we get the final answer. Now in the fifth question, we have a, a rectilinear motion in which a paratrooper jumps from a height h. There's a uniform deceleration due to the parachute of just 2 meters per second, and we need to find the height above ground at which the parachute must be open so that when the paratrooper touches ground, it is with zero velocity. Now we can use the third equation of motion, v square minus u square equal to 2gs. When we use that, we get minus v1 square equal to 2gs square and 0 equal to 2gs1 minus 2gs2. When we put in the values for the deceleration when the parachute is open and deceleration when the parachute is closed. Now when we equate 2gs1 equal to 2as2, the 2 gets cancelled. G is 10 and A is 5, A is 2, and then when we cancel that also out, we get 1 by 5. This is 10, not 5. And then when we assume the total height to be h minus s2 gives the value of s1. So h minus s2 equal to 1 by 5 when h minus s2 is divided by s2. So we get 5h minus 5s2 equal to 1s2, and then we get s2 by h is 5 by 6 and s2 equal to 5h by 6. The sixth question is related to projectile motion as well as relative motion. When the particles have to have the minimum distance between them, that time the particles collide. That's what is given in the question. So we need to find the horizontal distance between them when the second projectile has been projected. Since they collide when projected, they have to move along the same ring. That is, this distance has to stay constant throughout. But that is not possible when the particle is directly below each other. Only when the particle is directly below each other will they collide. Thus P1, this has to be above P2, which is this. Thus we get the distance between them horizontally as 0. In the seventh question, it is given that a projectile is projected upward from ground with an initial velocity u at theta to the vertical, which means the angle to the horizontal is 90 minus theta. We could directly use the formula velocity equal to under root of the y component square plus the x component square. The y component square we get as u cos theta minus gt, and the x component is u sin theta. When we expand this, we get u square cos square theta plus u square sin square theta, which equates to u square, and we have plus g square t square, and we get minus 2xy when we expand x minus y whole square, so we get minus 2u cos theta gt, and we get C as the answer. In the eighth question, it is given that two masses have been dropped from a height h1 and h2. We have to find the ratio of their times to reach the ground. Now in the formula for time, we have t equal to under root of 2h by g. Thus time depends only on the height and not the mass of the body. Irrespective of the mass, the time can vary or not vary. So we have T1 is root 2 H1 by G and T2 is root 2 H2 by G. When we take the ratio of T1 is to T2, the root 2 by G gets cancelled from both sides and we have root H1 is to root H2. That is option D. In the ninth question, a body is thrown up from a tower. We have to find the ratio of upward time and downward time when the distance to displacement ratio equal to n. Now the distance traveled up as well as down is equated as s1 and s2. So we have s1 plus s2 equal to distance and s2 minus s1 equal to displacement. N obviously is the distance to the displacement, so s2 plus s1 by s2 minus s1, and we can apply the formulas for ratio and we get n plus 1 by n minus 1 equal to s2 by s1. So we get under root of n minus 1 by under root of n plus 1 equal to t1 by t2. Why we take t1 by t2 directly is when we use the second equation of motion, the half g gets cancelled from both sides. We could also do this in another way if it was projectile motion. If it was projectile motion, we take t equal to under root of 2g into s1 by 2 s1 by g, and the root 2 by g would get cancelled. In the 10th question, a ball is bouncing between two walls with a constant speed, which means that the velocity only differs with respect to its direction and not with respect to the magnitude. Thus, when we plot the v to s graph, we get two different lines at the same values for x-axis, because when the particle moves from A to B, it has a particular positive velocity, and when it moves back from B to A, it has a negative velocity of the same magnitude, and the displacement also decreases.